All right, so now we're going to look at horizontal asymptotes. All right, so the line y equals b is a horizontal asymptote of the graph. If as x increases, the graph approaches the that horizontal asymptote. So in other words, the function is going to get closer and closer to the horizontal asymptote. And it's what's happening as x gets very large or very small, approaches positive or negative infinity. So rational functions can only have one horizontal asymptote as the x values approach positive or negative infinity. Some rational functions will have no horizontal asymptotes. A rational function may sometimes cross a horizontal asymptote once. If that happens, it's going to be in the middle of the graph, around 0. As x increases or decreases, though, the function gets closer and closer to the asymptote, even if it has already crossed the horizontal asymptote. All right, so we have some rules for finding horizontal asymptotes. If the numerator has the smaller degree, the horizontal asymptote is always going to be y equals 0. If the numerator and the denominator have the same degree, the horizontal asymptote is going to be y equals the ratio of the, let's put LC for a leading coefficient, LC numerator and LC denominator. Right? They're like running a race and they're tying each other. So it's going to be the ratio of those coefficients. So and below you have y equals the leading coefficient of the numerator over the leading coefficient of the denominator. Of course, that is the coefficient that is on the term with the largest exponent. If the numerator has the greater degree, there is no horizontal asymptote. We're not just going to be looking at those. We're going to be looking at ones that do have horizontal asymptotes. And then if something is added to the function, the horizontal asymptote is increased by that amount because it shifts the graph up or down. I guess I should say increased or decreased. Because if it's negative, it's obviously going to be decreased. So go ahead and add or decreased in there. All right, so we're going to find the horizontal asymptotes here. In the first one, the numerator is degree 0 because it doesn't even have an x. The denominator is degree 1. All right, 1 beats 0, so the numerator has the smaller degree. The horizontal asymptote is y equals 0. In the second one, the numerator is degree 0, and the denominator is degree 1. So it would have been, the horizontal asymptote would have been y equals 0, except the graph has been shifted down 4. All right, see that minus 4 at the end? All right, so the graph is shifted, I think I'm running into the next question, is shifted down 4. So that means that the horizontal asymptote is now going to be y equals negative 4. It was 0, we shifted the graph down 4, and so now it's y equals negative 4. In the next example, the numerator is degree 1. Right, you do have an x. My E is starting to look like an R. And the denominator is also degree 1. They are the same degree. So the horizontal asymptote is going to be the ratio of those coefficients. So the horizontal asymptote is now y equals 3/5, which is the ratio of the leading coefficients. And in the last example, the numerator is degree 2. It's got an x squared. The denominator is also degree 2 because it has an x squared. So again, it's going to be the ratio of those coefficients. And if there's nothing in front, it's understood to be 1. So the horizontal asymptote is again y equals 3, and because that is the ratio of the leading coefficients. All right? And that's all there is to finding horizontal asymptotes. It's pretty easy. It's y equals 0 if the numerator has the smaller degree. It's you add or subtract into that if something is added or subtracted to the whole function. And if they have the same degree, it's the ratio of the coefficients. I think this might be the end of this particular video. So this one wasn't too long at 6 minutes. Thanks for watching, and bye for now.